now we're seeing the industry really trying to adopt AI as a fundamental part of medicine. And I think COVID really helped. We never fully let the technology take over. Even though we have AI and we use AI different tools, there's always something that we do which is called human in the loop.
Hello, everyone. Welcome to one more episode of Unlocking the AI Advantage, a podcast. And this is your host, Ramesh Danta. Again, I'm recording these episodes from Health Conference in Las Vegas. And so today I'll be talking to an exciting company. I think company that you will realize it's really doing revolutionary stuff. So let me introduce you, Ash Anwar from Molecular U. Ash, welcome.
Thank you. It's a pleasure to be here.
All right, Ash. So let's get started with what is Molecular U company is all about. So if you could introduce Molecular U, please.
Yeah, absolutely. So Molecular U, we're a precision medicine company. And essentially what we do is we have a blood test that includes over 250 biomarkers. We're analyzing all the metabolites and proteins in the body. So the proteins are the structural and functional elements in the body. And the metabolites are essentially the byproducts of the chemical reactions that occur in the body. And we do this through a blood test, essentially. So we take 2 vials of blood, we analyze it through a liquid chromatography mass spectrometer, which is a very advanced machine, allows us to get very quantifiable, exact measurements of these biomarkers. And what we've developed is we've developed these biological signatures from these biomarkers that help us forecast different chronic illnesses or health issues that an individual might be trending towards based on their blood profiles.
So Ash, and when did you get started with the company, for example?
Yeah, so I've been with the company for almost 10 years now. So really,
Is Molecular U 10 years old?
yeah, almost since inception, right? And we've when we established the company and I was there, the idea was really revolutionary. It was like, how do we look at these early indicators of disease, like the biomarkers that I've been speaking about, and how do we develop these signatures that help us predict these illnesses? And so the whole premise of it was really to establish a preventative measure in essentially, and we've really grown from that. And it was, I think, in retrospect, when I think about it, I think it was really ahead of its time. People weren't really speaking about, they weren't really speaking about precision medicine. They weren't really speaking about using AI. And at that time, AI, it was really like data science and maybe fancy statistics, right?
Correct. Yeah, 10 years ago I was thinking about, yeah.
Yeah. So we were really like developing these models, and we wanted to make sure that the company was very scientifically sound and wanted to be sure that there was a lot of validation. So it's not just about building these predictive models, for example, but taking the predictive models, validating them, increasing the training data sets as much as we could, taking these things from an academic research perspective, and then moving them into like the clinical space. Like, can we validate these models in real world scenarios? And over the course of that decade, that's where we are now. And now we're seeing the industry catch up and really trying to adopt AI as a fundamental part of medicine. And I think COVID really helped. I think when the pandemic happened, it disrupted a lot of industries, and industries had to put their technology hats on and really wanted to advance and use these tools at their disposal. And now that we're past that pandemic point, now we have physicians in the healthcare industry who are more attuned to what AI is, more receptive to what it is. There's slowly been the acceptance and increase in trust of these tools. And at Molecular U, what we like to do as well is we never fully let the technology take over. Even though we have AI and we use AI different tools, there's always something that we do which is called human in the loop. There's always a clinical scientist or someone like myself with like a scientist background and training in these omic technologies who are always overseeing and supervising the models to make sure that they are accurate and sound in their output.
Okay. So if you it's 10 years ago, right? So data science is being so if we can go a little into the technology side, not too deep, but for example, what kind of models are you AI models? So without giving any secret sauce away, I'm not asking any of that one. To the generic, like so, somebody a data scientist they're curious as to what is Ash playing with, what kind of models, if you could.
Yeah, no, absolutely. I think there's a variety of models actually because like, it depends on.
Obviously, it has to be a variety. Yeah.
Yeah, and then, different chronic diseases progress and the data interacts, the biomarkers interact differently. So very common, like just off the top of my head, there's, a lot of regression models that would be using on a simple side. Yeah. And then support vector machines become very popular as well. And then as we get into more and more complex interactions, that's when we are using neural nets, deep learning kind of things. And one of our projects now is now that generative AI and ChatGPT is out there, we want to look in towards using generative AI to kind of create summaries from our data. But that's kind of built certain issues where the issue of hallucination is really great, especially when it comes to the scientific data. And you want to make sure that physicians don't get information that can be misleading, right? So we're working on a project now where it's more of a retrieval, like the RAG system, like retrieving information from a database of trained data, so that we could make sure that the impact or the issue of hallucination is minimized when it comes to that generative kind of capacity.
Okay. So when you guys started, did you focus on specific diseases or for biomarkers? I mean, now you have a plethora of, I mean, lots of biomarkers. But what was your starting point?
Our starting point was actually 600 diseases. Yeah, so we went the opposite way. We decided to do a massive survey of the literature of all the scientific knowledge that was out there and match to our existing panel of biomarkers. And it was more of a exclusionary kind of mechanism. So if there are biomarkers that don't have sufficient evidence for a certain disease, we would remove that from the platform and say, okay, this is not going to go into our product. And we narrow it down to a list of, I think right now we have about 15 diseases. And these are always like, they're always under review, making sure that they are up to the accuracy that we want. And if not, we want to remove them. And one of the thresholds we use is when we're creating these different models, like regression models, for example, we'll use data to create ROC curves and maintain that a threshold of 80% area under curve, for example, is our minimum threshold for these model accuracies. So we're constantly reviewing with new data, updating that. And so now we're on 15 diseases. But one of the things we've really noticed, and working very closely with functional doctors and other clinicians, is that they really want to get at the root cause or root mechanisms of disease. And so we've included this new feature in our platform now that is around the biological pathways. So these are things that you might remember from, any sort of like biochemistry class or biology class. Pathways like the Krebs cycle that govern energy metabolism, the coagulation pathway, for example, or the complement pathway that is involved in the innate immune system. So we have 12 biological pathways that we now have included, and this is really helpful for the clinicians when they want to look at a patient who might have a certain disorder, but now they can understand what is the biological mechanism that's driving that disorder.
Okay. So let's talk, Ash, about your own journey. Like, so 10 years as a data scientist, I'm sure you have grown a lot. So I think our audience will also benefit from looking at your journey. So originally, you started with the company as a data scientist. Or were you a data scientist or were you?
Oh.
Uh,
My background is actually in the sciences. So my undergraduate is in biochemistry. Yeah. And then I did my graduate work in experimental medicine from the University of British Columbia. And my research was really focused on neurological disorders like Alzheimer's and multiple sclerosis. And then I went to Harvard to do my research fellowship in ophthalmology. So I was studying age-related macular degeneration. And no, I was full-on scientist, biochemical neuroscientist, basically. And at Harvard, I was really looking at my research, we were creating a lot of statistical bioinformatic models, and I became curious with data science. So I would say I'm a very self-taught data scientist. I started picking up these different tools, learning Python, being able to create these models and everything. And then I came back to Vancouver. I met with Rob, who you're going to speak to tomorrow, and I guess he really liked me. He liked what I've been doing, and he brought me into this company and was like, "Hey, we're launching this. Would you love to be a part of it?" And I was like, "Absolutely." My whole ethos of my career has been how do we take research and translate it into like the practice, right? The whole concept was bench to bench side, right? So I was really excited. I joined Molecular U, helped kind of build this entire database of biomarker information and algorithms from the ground up. Now I lead the team that reviews all this data and creates a lot of our algorithms and signatures for prediction. And the company, I'm very much in love with this company. They've been uh, very helpful for me. And in between, I was able to complete my MBA from UBC Sauder as well. So that's been really beneficial to now understand the business side of things.
Interesting. So your journey is not like you didn't come from information technology into the biosciences. You actually you came from biotech,
Yeah.
right? And then you have learned to be an information technology specialist, and you've learned all that stuff, right? So how does it work? Now I'm sure you're working with a team of data scientists who come from a data science background. So I mean, you definitely have a lot to offer from the domain specific side because you understand that you've done a lot of research. Is that your actually strength? Actually, I could look at that as your strength because now you could tell the data scientists who may or may not care too much about the domain, but they're focusing so much on Python, data and models, and all that stuff.
Right. Yeah. No, that's exactly correct. I think being able to have domain expertise has been really an advantage, especially working with biological data. Yeah. And now that we're leading with, now that I'm working very closely with, our exceptional team of data scientists and data engineers, you know, th- it's not like I have expertise in the entire technical field. They are always teaching me things as well. I'm very grateful for that as well. I love to learn these kind of things. But being able to be there and help them guide through some of the biological domain information has been really valuable as well. And we had a data scientist we hired, very exceptional data scientist in the past, but his experience was working with mostly financial data. And I think that's where the difference became really apparent, where he was struggling a little bit with kind of how biological data interacts. And it's not the typical like forecasting like financial models. He was an exceptional data scientist, but the domain expertise was not as prevalent there and lacking a little bit. So, when we look to hire data scientists, we look for people who not only have these technical skills, but understand some level of biology to give them that underpinning.
Yeah. Is that your advice? Because right now at a flux in terms of career, right? With respect to people are confused. Just learning Python itself is not sufficient. Like a coding is okay. Now you can get co-pilots and all that stuff, right? So now people are a little confused to what to do, right? So in that case, you want them to learn about the domain of the industry they're going in, not just be it the coding geeks or something.
Yeah, yeah, no, I completely agree with that. I think it would be, my advice would be to really pick an industry and a field that you're interested in. And it could be finance, it could be operations, biology, like whatever.
But for somebody who's doing a data science, computer science background, I mean, the domain expertise doesn't come naturally. They have to get a job to get the domain expert.
No, no, absolutely. But it's like I think that's where it's important to be open. Like the skills for Python and I'm gonna bring in like SQL in there as well, which is exceptional. Like databases are used everywhere, and I use Snowflake every day, so that's something I don't have expertise on, but I've had to learn and being able to use big data and things like that. So you can pick up these hard coded skills. It takes time, but you can definitely pick them up. And learning on the job is really key. You just have to be open to that expertise of picking up these skills and being open to not knowing and then being curious to learn. And then, as you mentioned, there's a lot of tools that are available now. They weren't available during my time, but they're available now that you don't have to be a perfect coder. So that's what limited me in my programming, where, I have some level of programming. I've done C++, for example. I've done Python, SQL, but I'm one of those people who tends to make mistakes in my code. And debugging is a very painful process. So that's what really turned me off from coding. But now with a lot of these tools, those things are automatically fixed for me. The code can be optimized, and that's been like a really big helpful thing. And so it's the domain expertise and my willingness to continuously expand my learning, do my business degree, for example, has been the one that's really propelled me as forward as I could get so far.
So, what are you? This is the last question, Ash. So, I mean, what are you noticing in your data science team with the tools that are available now? Right. So, it's like, for example, ChatGPT. There isn't a demo of I can give a screen, upload it into it, it spits out the code kind of a thing, right? I mean, that's where we are. So, even though it cannot make a complete app, right? So, are you noticing from your data science team the productivity has increased, or if somebody who knows how to use the tools, right, versus somebody who doesn't know how to use the tools, or not spending enough time to learn how to use the latest AI tools to do the coding, are you noticing any differences in terms of like 2 years ago, how they've been programming coding versus what they're doing right now?
Yeah. I think there's been a big boon with using these AI tools.
Is it a promise or is it reality? Like, are you noticing it?
I think it's the reality. Yeah, the reality. I think they're being able to use these tools that are out there like ChatGPT, these other AI tools, only enhance and increase the efficiency of how someone can work. It is not. It's not. When I'm working here with people who are using the data scientists who are using this, you can't completely trust the AI system to do everything for you. If you just put it in there and say, hey, create an app that does, XYZ, it's not going to be able to output it in the way you want. You still need to have the right requisite knowledge to build that. But being able to, let's say, build a module, like you want to build an API connector or something like that, you can just throw it in and it will help you build a framework from which you can add and put in those customizabilities. So it really enhances and speeds up the process. Instead of having to write code from scratch, you can output code in modules, piece it together to then create the full product at the end.
Okay, so but that is awesome, in the input there, because I was very curious as to what's happening in that landscape, right? So a lot of confusion out there, in terms of the people who are doing whether they should do computer science, or 2 years from now it's no longer needed.
Oh, no. I think there's a lot of fear with artificial intelligence, a lot of hyperbole, like myth, like, oh, it's when ChatGPT came out, oh, that's it. Like people are like, oh, we're gonna lose a job, it's over. It's not hasn't been the case. I think the only thing it's done is enhance the ability to do these tasks. You're still gonna need people who understand the context, be able to troubleshoot and fix. And what I think it's done is it's pushed a lot of people's jobs and careers into being able to think. And I think that's where humanity really differentiates itself. It's in the creative thinking, the imagination, the ability to problem solve. And ChatGPT or these AI tools can help you do a lot of the repetitious tasks or tasks that require a base level of understanding. I don't think we're there with true AI yet, where it will completely take over. But yeah, like a good example is ChatGPT is only as good as the data it's been trained on. Yeah.
Yeah, and then also, it's as good as the prompt that you can put in, right? So the kind of the question, right? So the data is there, the models are there, but let's say you and me, so I've put some stupid prompt or a very basic prompt versus you put a very sophisticated prompt, you will obviously get a better output than me.
Exactly. So we're gonna start to see new jobs, right? The prompt engineer.
Prompt engineer, this is already there.
Yeah, exactly. So it'll enhance it. The industry is shifting as it's always done. When we had the Industrial Revolution, people were worried about automation is going to take jobs. It took some jobs, but it opened up No. Exactly.
Good. Hey, Ash, good luck to you with Molecular U and good luck to Molecular U. I think you guys have already made a lot of progress. So congratulations on the Rising Stars Award at, the health. Was it part of, which competition was it part of?
It was part of the longevity.
Oh, okay, okay. So that's good. So good luck.
Thank you
Take
so
care.
much. I really appreciate it.
Thank you very much.